before getting into setting up any tool, you again have to go to the picture to determine whether it is a MapReduce based tool or a non-MapReduce based tool. And if it is a MapReduce based tool, you need not to worry much about changing the existing configurations. But if you are developing a non-MapReduce tool, you have to make sure you adjust resources between existing non-MapReduce and MapReduce tools to accommodate the new non-MapReduce based tool. But for the MapReduce based tools, there is no need of adjusting resources. You can just deploy any new tool which runs using MapReduce. Now we are talking about Oozie, and the picture suggests it's a MapReduce based tool. So there is no need to adjust any of the memory or other resources for the existing tools in the cluster. You can just go ahead and start deploying the Oozie. Okay. So again, we will follow the similar approach. First, we will see the overview of Oozie. Then we will talk about architecture of Oozie, and then we will set up Oozie using Cloud Manager, and we will look into Oozie parameter files, log files, and we will see a demo. So again, Oozie is a MapReduce based workflow tool. It facilitates you to define workflows for related jobs. So first we need to understand the term workflow. Most of the, as most of you are experienced, you might have already know what workflow is. It is nothing but a flow for a dependent jobs. And most of the tools use XML to represent the workflows. In more technical terms, a workflow is nothing but a directed acyclic graph, and it will be stored as XML. The XML for Oozie is termed as HPDL. I'm not sure what the abbreviation for that is, but it is termed as HPDL. It runs the entire workflow using one or more MapReduce jobs. In larger clusters, gateway nodes can become bottlenecks, and Oozie can mitigate that issue as jobs run in the cluster in the form of MapReduce programs. So the main difference between one of the advantages of using Oozie is typically when you run MapReduce jobs using commands like this. Using commands like Hadoop jar, what will happen is it will take enough resources from this node, which is 15, because it has to keep track of the progress of the job by getting the information from the resource manager. So when I run this job, what will happen is it will take few CPU threads, and it will hold the control until the job is run, and also it will start getting the information from the resource manager about the progress of the job. So it will take time for you. It will take few resources on the gateways. So let's take an example of a very large cluster which has hundreds of nodes, and where you end up running thousands of jobs on regular basis. At that time, what can happen is even if you have 2 or 3 gateway nodes in the cluster, it can take a lot of resources just to submit the jobs and to get this information from the jobs. Okay. So if you use Oozie, what will happen is the job process which we are getting will be outsourced to the nodes in the cluster. So instead of even this one will be a MapReduce job, the one which is keep track of the progress of the job from the resource manager also will be a MapReduce job. So when you have thousands of jobs running in the cluster, it will be distributed across the cluster, all the job invocations. So in the previous case, when we run this command, we just invoked the job. So even the job invocations you can push it to the Hadoop cluster, and then it can distribute the job invocations as well in very large Hadoop clusters. So Oozie can come handy to reduce the load on the gateway nodes. Your gateway nodes will just submit the Oozie jobs if you are using if you want to use Oozie. But in the smaller clusters, it is not practical to use Oozie. Instead, you should use gateway to submit jobs. Instead, you should use gateways. The reason is, as I mentioned to you, Oozie will the job invocation will also be a MapReduce job. So it can take a lot of resources on the cluster in a small clusters. So, but in a larger cluster, you can pass on the job invocations to the all the slaves in the cluster, which runs the task trackers or node managers, and then the load on the gateways will go down considerably. So that this is what the statement is. In larger clusters, gateway nodes can become bottlenecks, and Oozie can mitigate that issue as jobs are run in the cluster in the form of MapReduce programs. It is integrated with most of the Hadoop ecosystem tools, so you can use most of the Hadoop jobs related to most of the Hadoop ecosystem tools, not just the command like this. You can run Hive queries, you can run big queries, you can run scoop jobs, everything using Oozie. And more importantly, you can even create the dependencies between them in Oozie, and you can actually execute coordinated jobs using the Oozie schedulers. Using the Oozie workflow. And it has two components. One is workflow and scheduler. Scheduler is not that important because you can define workflow using Oozie and integrate with Rival Enterprise Scheduler. So scheduler is not that important, and I didn't see many people using the Oozie scheduler, but Oozie workflows are used in many of the applications where you have multiple jobs that needs to be run in coordinated fashion. This is the architecture of Oozie. It can support almost all the ecosystem tools. So that's why we have SDFS at the bottom and then MapReduce. It could be I am talking about the slaves. So when it comes to slaves, data node is the slave for SDFS. Name node or a task tracker, depending upon the framework you have chosen for your MapReduce, is slave for processing the job. And then you have ecosystem slaves if you are using non-MapReduce jobs. For example, if you are using Impala, the ecosystem slave for Impala will be Impala D. Similarly, if you use HBase, it will be region server. So it can work on all these things. Slave is nothing but a slave node in the Hadoop cluster, and then you have a bunch of masters, which could be ecosystem masters or MapReduce masters or HDFS master, and then you will have another master, which will be termed as Oozie server. So typically, this will be running on a gateway or some other node, which is designated as Oozie server. And Oozie uses a repository to store the workflows, the HPDL or directed acyclic graphs, which are stored as the XML, which is termed as HPDL. There needs to be a repository to store those things, and it uses a typical relational database to do that. And default, it uses Delby. Delby is the in-memory database, and in production, we do not use database like Delby. So we have to reconfigure it to use MySQL. And then there will be command line interface for Oozie, and also there is a web interface. When it comes to command line interface, there is nothing like Hive where you can launch Oozie command line interface. You can just submit the commands and you can monitor it. So Oozie command line interface is like Hadoop SS. or mapred, something like that. It will execute the job and it will immediately give you the control. It is not like hive or pig or it is not like hive or pig or HBase, where it will actually launch their own command line prompt interface and where you execute a hive query or a pig command or a HBase command. It is just it will just look like this, and we will see as part of the demo. And the Oozie command line is used to submit the jobs and monitor the jobs that will be running as MapReduce jobs. Yeah. So ecosystem master, as I mentioned to you earlier, apart from HDFS and MapReduce, we have non-MapReduce tools also in the cluster. And the example are HBase or Impala. Instead of defining all the masters, I just grouped them as ecosystem masters. So if you are talking about HBase, the master for HBase is HMaster, HMaster, and the slave is the region server. And if you are talking about Impala, the master is state store D or catalog D, and the slaves are Impala D. And if you talk about any other tool, like Spark or Presto or any non-MapReduce tool, you will definitely have a master and slave for that ecosystem tool. So instead of separating it out for each of the tool, I just categorized all the non-MapReduce tools into ecosystem, and I have depicted as masters and slaves with same colored box. Okay, so Oozie architecture, I'm putting it in words. So it requires a Oozie repository, which is a database to store workflow destinations and details. And we will have a Oozie server, and we will have a client. We have to configure all these things now using Cloud Manager. So setup by configuring Oozie server alone. It uses Delphi as database by default, but Cloud Manager does not let you change the default. This statement is not correct. I will fix that. So let me first set up. Yeah, I know why I put like this. I will show you what the second statement means. Okay, it is a little bit tricky. So, for example, if you look at Hive, if you click on configuration, and if you click on Hive Metastore, so Metastore we use database, and somewhere there should be some database too. Yeah. So if you are using Hive, under service wide, so you can actually check like this, and you can choose the database, and then you can give the database name, database host. Database name, database host, and port number, and the username and password. You can directly change the settings like this in Hive, but whereas in Oozie, it does not provide facility like this. So that's why I'm saying that it uses Delphi as a database by default, but it does not let you change the default directly like that. You have to use the safety valve approach to configure that, and we will see that now. Okay, so to add the service, go to Home on the Cloud Manager and click on the small square and click on Add a Service. Oh, I have already added that. Okay. Don't know that I have added that, but that is fine. Let me see. Leave page. Let me stop it and let me delete it, and then I will start. Yeah, I know why I have configured it last week, because to show you the hue, hue has the dependency on Oozie, so that's why I end up creating Oozie as well. Okay, let me delete hue first, and then delete Oozie also, and now we'll start setting up the Oozie service. So click on this, click on add a service, and then select Oozie, hit continue. So by default, it uses the HDFS for storage and YARN for processing, the MapReduce based processing. And the Zookeeper, it requires because it can work with tools like HBase and all those things. So as we already have Zookeeper, it is picking up automatically. So you have to select this, it will be automatically selected, you cannot unselect it. Then you can hit continue. And here you have to configure the Oozie server. Let's make 6 as a Oozie server and click on OK. Okay, hit continue. Okay, so if you remember Hive configuration, when we actually add the Hive service, it asked you for the database, it picked Postgres by default for Hive Metastore, and then we have changed it to MySQL, and then we have provided the information accordingly. In this case, it is not giving that option. So Cloud Data Manager is not flexible enough to reconfigure at the time of adding the service itself. So the workaround is you have to add the service, and then you have to configure the reconfigure the database from DB to whatever database you want to. In our case, we will be using MySQL. So before it is almost done. In the meantime, we will see the steps to customize the Oozie repository with MySQL database. Go to the host on which Oozie server is running, and then we have to install MySQL connector. In our case, we have configured Oozie server on NoviSync CDH 506. So we have to go to that service and then a server, and then we have to install MySQL connector. The reason why we need to install MySQL connector is without MySQL connector, that host will not be able to connect to your MySQL database. In our case, MySQL database is on NoviSync CDH 500, which is our gateway node as well. So let's do that now. So I'm going to 506. Okay, so the steps are cat 12 setup Oozie.txt. It has the steps. Oh, I don't have this. I thought I have added that, but I can add it pretty fast. Okay, so I have for scoop. I have it in scoop, so I can use the steps. So the way you can add MySQL connector on 6 is by running this command. Okay. So let me update the other one also. Setup. Steps required to set up Oozie repository in MySQL. Oozie. Once it is done, you have to go to the host where MySQL database is running. Then MySQL -u root -p, create database Oozie, create user Oozie identified by Hadoop 20 or whatever password you want to give, and then you can grant all Oozie.star to Oozie, and then you have to flush privileges. So this is how and these are the commands which you need to execute. So still we are installing the connector. Use safety valve to update database connectivity parameters to MySQL for Oozie repository. Okay. So now we have installed connector. Connector is just to connect to the MySQL database on other source. It actually does not install any database here. Okay. So we have to create this soft link, or you can copy the MySQL connector java.jar to varlib Oozie. You can either create a soft link, or you can do a physical copy of the jar file to varlib Oozie. In this case, I am just creating a soft link. I have to use sudo. Okay, it is done. Now we have to go to our gateway node where we have our MySQL database. Login as root, HD user, and then MySQL -u root -p Hadoop 20, and show databases. There is no database for Oozie. We can use the existing database also, but that is not a good practice. We should have our own database for each of our tools, so that if there are tables with the same names, they will not conflict with each other. Okay. So for that reason, we are creating the database user, and also we are granting the permission. Grant all Oozie.star to. Okay. Let me check the scope one, high one, not this one. Grant all on to deck. Yeah. Okay, not the problem. Create user. Okay, grant all on. That is the problem. Okay. Okay, it's just the syntax issue. And then flush privileges. So now we have the database ready. We can go to the configuration using our Cloudera manager. Click on continue, finish, and then click on Oozie, stop the service. So always when you are updating the parameter files, especially okay, correct. Okay, thank you. So always when you are changing parameters like this, which are core for the service, like changing the database and all, you should stop the service first. That way, it can you will be saved from surprises. That is the best practice. Okay, it's part of the configuration. Click on configuration, and you can click on the database, and it says there be. We want to use MySQL, and database name is Oozie, and localhost. Okay, IP 10.0.0 and I think they changed they fixed some issues. I think that's why I'm able to change it. In the earlier versions, it did not let me change it like that. Hadoop 20. So I have to fix my PPT also. Okay, so we are actually directly changing most of the stuff from Cloudera Manager itself. And username is Oozie. Password is also Oozie. Okay, and that's it. But we are actually changing from Deadbeat to Oozie. So Oozie requires certain set of tables to support the repository in the database. So to create the tables in the database, there are multiple ways to do that. If you go to the documentation, you can get the instructions. But the more straightforward or easy way is to reset a parameter. I think I have it here. The database category also enable create database by adding a parameter using safety valve for Oozie site.xml. So there is a parameter which actually tells you to create the tables. So for that you have to use the safety valve, and you to go to the safety valve, it will be always under the advanced. You click on advanced, and then you have to click on this, because we have to update it. We have to add a new. We have to update a parameter which is not visible in this. First, let us decide what the parameter is. So when we actually set up the Oozie server, again you need to be aware of the location where the runtime parameter will be stored. So I'm sudoing to root, and it will be under cd val run Cloudera SCM agent process, and this is the one which you need to be aware of. Which you need to look into. So go to the directory, and you will see the Oozie site.xml file. and you can view, and there will be a database. See, it is using Derby by default. Now we are changing to okay. Okay, I think what we can do is create equal to true. Should there should be a parameter which says, okay, let me restart it, then probably it might. Okay, save changes and start. Okay, it will take little time to start. So it says failed. And let's see what the issue is. Could not load service classes. The driver has not received any packets from the server. Yeah. It says connection refused. Okay, I think I haven't set the port number correctly. So go to Oozie, click on configuration, and under Oozie server, this thing. Yeah, where is the port number? Here, 3306. Save changes, and then click on start. You can also look at the logs under where log, cd, Oozie, LSLTR, tail minus f. Still it is giving the connection refused error. The driver has not received any packet from the server. Let us troubleshoot the issue. Okay, think I think Oozie configuration database. Yeah, I have given the wrong. We have to give the MySQL database host. I have given the Oozie server host here. Okay, this is database host. Now save changes, update password, and click on start. Still it is giving the issue. Yeah, now it is saying access denied. So we are getting a different error. That means we have not given the password correctly. Okay, that's good sign. Password is Hadoop 20. So save changes, update password, start. Okay, so after changing the IP address to the correct host, we got the access denied issue, and we changed the password. I hope it is correct this time. And let's see what will happen this time. This time also it is giving an error. And what is the error? Now it is saying table does not exist. So the issue is there is a parameter which we have to change to true, and I'm trying to figure out that parameter. Let me check that. Now let me go to var run Cloudera SCM agent process lsltr, pick the latest one, 69 lsltr, and here oodisite.xml. Okay, it is not. Let me Google it. cd etc Oozie conf. Yeah. Allocation survey. No, this is not the one. Yeah, this is the one. So we have to set this to true. Okay, this is the thing which you need to set it to true. And for that, we have to use the safety wall, because if you search for the parameter, let me try to search for the parameter. Probably they might have changed in the latest version. Okay, there is no such parameter. So we have to add it using safety valve. And the safety valves are typically under advanced. You can click on advanced, and here you can click on it, and then you can copy this entire property. So safety valve, you have to update properties in its original syntax. If it is XML file, it should be the property tag which you need to add. If it is a properties file, it should be a key equal to value or whatever syntax that actual properties file does use. Sometimes they use space between key and value. Sometimes they use equal. So you need to understand, you need to be aware of the actual properties file syntax, and you should use that one. If it is XML, typically you will have a property tag, which will have name tag and value tag. And in this case, we have to change the value tag to true. Description is optional, so you can remove if you do not want, or if you can leave it like that. So once you do that, save changes. So what this parameter will do is, if the database does not exist, it will create the database. Sorry, it will create the tables or database, depending upon the situation or the database. In some cases, you have to create the database and set to true, and it will start creating the tables. In some cases, like Oracle, it will create both user and the tables. So depending upon the database, the behavior can change. With MySQL, you have to pre-create the database, and then you have to set this parameter to true so that all the tables are created. when it runs for the first time. Now click on start, and you can actually go to varlog again, cd varlog Oozie, and then tail -s. So now it started successfully. So you can monitor the way I have done now from the server wall as well. So close it. Now it started successfully. Yeah. Now the status is green and it is up and running. Okay. So that's the way you have to set up. The only complexity is to reconfigure the repository. You can use the Cloudera manager to change all the settings, but you have to use safety valve to update that parameter so that it creates the database, the tables that are required in the database. Let me show you what it has done behind the scenes. So let's go to the server 15, where we have the MySQL database, which we have used for the repository, and see what have happened. Okay, again you have to do MySQL -u. Our username is Oozie, and password is Hadoop 20, and you can say show tables, use Oozie. So we have to switch to the database which you want to look at, and you can click on you can type show tables, and these are the tables that are created by the Oozie when it runs for the first time if the table does not exist, and then these tables will be used to store the workflows of your Oozie jobs, or the XMLs of your Oozie workflows. That being said, the setup is done, and we are now using the MySQL for the repository of Delphi. And also we have seen Oozie site.xml file. It will be typically under etc Oozie conf for the systems which are not using Cloudera Manager. But if your cluster is using Cloudera Manager, then it will be looking into you have to look into where run Cloudera SCM agent process to see the latest versions of your XML files. Yeah, let me complete the theory before the demo. We'll take the break. So these are the important parameters. Actually, I have all the parameters here. So Oozie base URL will give you the host name where your Oozie server is running. So then the Oozie DB schema name is the database name, and then we have a bunch of JPA service parameters starting from create schema to the JDBC driver. So depending upon the driver you are using, you have to provide the class. But as Cloudera Manager is providing that option to select MySQL or Delphi, depending upon the choice you made, this will be updated automatically. And this is the JDBC URL, and this one also will be updated automatically with the host name you provide and the port number, and then username and password for the database. And then there are these two parameters called whitelist. When we run the jobs as part of the demo, you will understand the significance of these parameters. Okay, and Oozie log files, I have already shown you when it is running. We looked into where log Oozie, and there is a log file for it, and it is controlled by log4j as any other tool in Hadoop ecosystem. And when the jobs are submitted, as it is using Yarn or classic MapReduce framework, you have to go to the respective logs to troubleshoot the issues of your MapReduce jobs submitted by submitted as part of the Oozie. Okay, and now we'll take a break of 10 minutes, and we'll talk about the we will do a demo on Oozie. Okay, so I'm pausing the recording. So now we'll be talking about demo. Okay. So as part of the demo, if you go to the scripts file, and there are multiple things in this which you can follow. Okay. The first thing is to check the status. Okay. And in this case, our Oozie server is 21. Okay, so you have to use the IP address. So Oozie admin, the command, and minus Oozie is the subcommand under Oozie admin, and this can actually give you the status of your Oozie server, and this one will give the version. Okay, so you can run this command on any node in the cluster. There is no concept of gateways for Oozie. Always you have to specify the Oozie server address, and then it will be able to connect to that, and from there it can determine the configuration because the configuration will already be updated on that server. But that server needs to be at least a gateway for all the services you want to use. Okay, we are on the gateway node, which is 15, and this one, new window. And you can run this command, and the mode is normal. There are a bunch of other commands also, but most of the stuff can be done from the Cloudera manager, I think minus start, minus stop, etc. But you need not use the command line interface if you are using monitoring tools. This command will give the version of the Oozie, which is 400 CDH521. And now we will set up the examples and see how we can run a sample Oozie job from the examples. Okay. For that, you can create a directory here, mkdir -p. This is not mandatory, but you can. It will be good if you do this. Demo Oozie, and then you can go to that directory, and you have to copy. There will be a examples.tar.gz. You have to copy and enter it, and the path will change depending upon the version of distribution, Cloudera distribution you are using. So the better way is by running the find command. Find. Let me do sudo find from the root directory by name Oozie examples .jar, .tar.gz. Okay, now it will show you the appropriate location, and you can copy this one. You can copy one either of them. Okay, and you can do cp to here. Now the tar file is copied. lsltr. You can run tar xvf to untar. It's just a tar command syntax. And now it will create a directory of examples. And you can go to examples, and the layout is src, which is I think source code, I think. For most of the stuff, we do not use this one that much. You can look what kind of files are there here by using this is the source code for the demo programs that is part of these examples. But we need not worry much about SRC. The main thing here is apps. Input data will have the input data for the example workflows in Oozie. So their data set is not very big, and all the examples in apps uses this input data directory for the data to process as part of the Oozie jobs. Okay, and the main directory under examples is apps. And if you look at all the directories under apps, there are a bunch of directories, and each one is related to a tool in Hadoop ecosystem. So you have MapReduce. So MapReduce is an example to invoke a MapReduce job using Oozie. Java main is an example to invoke a simple Java program using Oozie. You can even invoke non-Oozie stuff like cron. Streaming is something different, which is not covered in this. So it can not only support Hadoop ecosystem tools, it can also support non-Hadoop ecosystem tools. For example, cron. Cron is a Unix thing, and it also shell. Shell, you can use it to invoke the shell scripts. So there are different kinds of workflows that are supported by Oozie. Scoop is for scoop, pig is for pig, hive is for hive. These are all examples, and you can use these things as templates. And this is more than enough for administrators. Before turning around to developers, they should validate at least one or two types of workflows, and they can administrators can use these examples, and then they can validate, and then they can turn around to the developers after the maintenance. So as part of this, we will look into MapReduce example. So you can go to MapReduce directory, and you can do lsltr. So the main DAG, or direct acyclic graph, is workflow.xml. So this one will actually control the workflow. Okay, and then job.properties. So if you have any properties that needs to be reused across multiple jobs or multiple jobs, you can put it in the job.properties. Okay, and lib is for the jar files which needs to be executed. So this Oozie examples, this jar file have the source code you have seen earlier, and this one have the classes for the source code which you have seen earlier. You can run jar tvf on this command, and you can see user Java okay, jar. Then you can do lib. Okay, I have to give jar tvf. TVF will list the files in it, and if you see, these are all classes for which we have seen earlier in the source code directory. Okay, so this is compiled version of programs which include mapper and reducer, and these programs will be used when we actually invoke the workflow. And now let us see the job.properties and workflow.xml. If you look at job.properties, all it have is the name node, job tracker, queue name you need not worry, examples root is used here. So this will be used to determine the directory in HDFS. This is HDFS directory. So it starts with name node, then slash user, slash is the, after you give the name node, slash is the root in HDFS, and then user is the directory, and username will be the OS user, which will be automatically replaced at the time of the running the Oozie job. So in this case, we have logged in as HD user, so this will be replaced by HD user. And examples root is the variable parameter which is defined here. So this example float will be replaced by this examples, and you need to copy, once you modify these changes, you need to copy to this directory. You need to copy these examples to this directory, and you should be able to find this file in appropriate location after replacing these parameters like username and example float. We will see that in a moment. Okay, and this name node and job tracker, if you look at when you submit the job, it will try to connect to the local host and it will try to execute the job. And that is not the case in production clusters. You will have a you will have it a different node than local host for your name node and a different node for job tracker. In our case, we are using high availability. So what we have to use is we have to use the name service, not the actual IP address. So our name service is name service 1. And job tracker, we are using yarn, and the server is, the server is novice sync CDH504, and port number is 32, because we are using resource manager which from yarn. We have to use the port number 8032. If it is classic, it is 8021. Once you make those changes, you can come out of this and you can actually review the workflow.xml. So the main thing is this one. So this tag will tell what kind of action needs to be taken for this node in the graph. So if you have in this, there is only one action which is named as MR node, and the action is map reduce. This will tell which action is it. There is only one, but in a production kind of jobs, if you have multiple dependency map reduce jobs, map reduce programs that needs to be run, then you will see multiple actions like this, and this will control what type of action it is. In this case, it is map reduce. Similarly, if you go back to the apps, and if you, let me show you. Now, if you go back to pig, and if you look at the workflow, it is saying action name as pig node. And actually, we are trying to invoke pig. And then if you see hive, you will see hive here. If it is Java main, you will see Java main here. So depending upon the way you want to invoke, this needs to be changed. And these all will be driven by developers. You need not worry much about this. But I will show you an example which uses multiple types of actions, and that is from the from my application development demo, and I have something called connect the dots. No, yeah, I think this is the one, Oozie ETL. Okay, and yeah, this is the one. If you look at this, but not the job.properties. Workflow.xml, if you see this one. Let me view how to zoom in. I'm not sure how to zoom in. File, edit text. I'm not sure how to zoom. It is fine. Bear with me. But if you see this job, it's a means it invokes multiple MapReduce programs. One has MapReduce action, and the other one has pig. So we are invoking multiple actions in the same program. So this is how it will look like in a typical production kind of workflow job. You will have multiple actions, and you can define your workflow to coordinate any type of Hadoop application. It could be a MapReduce application, it could be a Pig application, it could be Hive, it could be Scoop. So if you think about it, if you have to get data from a source system and load into Hadoop, do ETL on top of that. And once the ETL is done, if you port the data back to the reporting layer, there are multiple steps involved in it. You might have to use Scoop job to get data from the source database into Hadoop. That is one type of action. And then you might have to do ETL using one or more types of actions. And then the third one will be once you do the ETL, you want to copy data back to the reporting layer. So there you will have at least 3 actions in that, and all these 3 actions have to be done in a coordinated fashion. And that's where Oozie comes into picture, and this is how more complex Oozie workflows will look like. But as I mentioned, you need not be aware of this in detail, but as long as you know basic syntax and as long as you can validate whether everything is running as expected or not, that is more than enough. Okay, again going back to the MapReduce. That's what I'm going there. I'm sorry. And now if you look at workflow.xml of the MapReduce, the action is MapReduce, and job tracker when name node, it will take it from the job.properties. You can either hardcode here or you can use the job.properties. If you hardcode here, this will take the precedence, but it will be best practice to use the job.properties. And there are multiple tags. For example, the prepare, if you remember when you run Hadoop jar command, if the target directory already exists, it will fail. So this prepare will take care of any prerequisites before running the MapReduce job, like creating the directories or deleting the directory, so that MapReduce job does not fail. And then this is a typical layout of invoking a MapReduce job using Oozie. You need to tell the queue name, mapper class, reducer class, map task, etc., which you need not worry much. And then after the action is done, there are 2 tags. One is OK tag and the other one is error tag. So OK tag is telling that if it is successful, then go to end. So in this tag, if you want to take a particular action, you can again elaborate this thing. In this case, we are not doing anything, so it will just come out cleanly as defined by the Oozie workflow. If it is error, it is going to fail tag. You can use message and send it as a message, and you should be able to, if you configure it properly, you should be able to capture these messages and page it out to the support team. Okay. And one more thing, when it comes to if you are talking about multiple action workflows, like I have explained earlier, where is it? So if you go back to this workflow.xml, if you see in the first MapReduce application, in the first action which uses MapReduce, if it is okay, I'm going to pig node. That's how we are defining the flow. Okay, this is the example of serial flow. You can even define the parallel flows also. So, for example, if you want to get the data from multiple sources, source tables, and then if you want to join the data, you can get the data from multiple tables in parallel. Once you get data from both the tables, then you can actually do processing on both the data sets like join. So the first one will be parallel, where we will read the data from 2 tables. And then there should be a next step where you will define the join logic to join both the data sets. So there is a way where you can actually fork parallel jobs and join them as well. So, but this example is for serial, but you can do parallel also. If you want to, for the examples for that, you can go through the Oozie user guide, and it have all more details about the complex workflows which requires running Oozie jobs in parallel, etc. But for admins, that is not required. But developers, definitely they have to look into those things. Okay, so now we have made the changes to the job.properties, and there is no need to change anything in the workflow. Now we have to copy this to Hadoop. So you have to do Hadoop SS minus put examples, user, HD user, and this example directory will be created under user HD user. Okay, now if you remember, VA examples, apps, map reduce. Let me do the cat int of VA. Cat examples, apps, map reduce, and job.properties. Right. So here it is saying that application is in this location. Okay. So before running the job, you should validate whether you can find this file or not in this location. For that, you have to run Hadoop SS minus ls. And then username is HD user. Examples, this examples is from here in the job.properties itself. And then apps, and then map reduce, and then workflow.xml. You should find that file. If there is no such file, and if you try to run the job, it will fail, and the others might not be might not make sense unless you get used to it. So first, make sure, unless you are comfortable with it, make sure that the files are as per the expectation, and then as we have the workflow.xml file, now you can actually run the Oozie job using this one. So in this case, our IP address is Oozie server's IP address, which is 21. Let me okay, and then you can copy these things. And here we are running Oozie from the OS command line. So it actually does not understand HDFS directly. Okay. So when you actually define minus config here, you have to give the local path, not the HDFS path. While submitting the job as part of the minus config, you have to give the local path. So which means you can give this one home HD user. This is the local path in the Linux, and then demo Oozie examples apps map reduce and job.properties. Okay, if you try to give the HDFS path, it will fail because it does not understand at this time about the HDFS when you pass it as minus config. Okay, there is something. Okay, I miss -1, and then you can give -1. It will give the job ID. This is Oozie job ID, and you can use this Oozie job ID to check the status. And for that, you can use info command, and you can give this ID. The syntax is Oozie job minus Oozie, our Oozie server address minus info, and give the job ID. It is still running. While running, because it submits map reduce jobs, you can actually monitor the job from the Resource Manager Web UI. Our Resource Manager Web UI is, now we sync 504, and if you see, we just submitted one job, but you can see two jobs. The first one is Oozie stuff. It just submit the MapReduce job. So if you run Hadoop job command, you will see only one MapReduce job. In this case, as Oozie is invoking the MapReduce job, Oozie itself also runs as MapReduce. You will typically see one job, for each MapReduce job, for each action actually. For each action, you will see one MapReduce job, which will actually invoke the actual business related MapReduce application. To understand that, you can click on history and you can click on configuration. Or actually in the overview itself, I think it will tell you something. Oozie launcher, now configuration. Yeah, this is the one. Job name. Here it is saying it as Oozie job. Let us see the. Okay, I know where to look at. So instead of doing here, you can go to the map task, click on here, and you can click on the logs. It will tell you what is going on behind the scenes. So it is actually it is actually launching the Oozie job. Okay, and the job ID is this one. Oozie launcher have propagated new Hadoop job ID to Oozie, and this is the next. This is the job ID which Oozie have submitted to invoke that MapReduce program. Now, if you go back to our Resource Manager UAE again, we have another job, and if you click on the application master of it, and if you click on the map task, yeah. So where is it? Not this one. Yeah, this is the one. This is the job which is submitted by Oozie, and you can go to counters, and you can see what is going on. This one have 33 records as input and 33 records as output. We will evaluate the input and output. To look at the output directory, you can click on reduce tasks, or you can go to the configuration, and you can search for the output directory. Yeah, output dir. Yeah, so this is the one. You can now look at this location to validate the job is successful, and we have the data. So you can see a bunch of files created just now. Okay, and you can even cat the files. So you can actually see the data. And the input is from you can actually look at the input directory also to confirm. So this is the actual data that is processed by the MapReduce job. And you can actually, I'm not getting into the details about the logic and all, So what this MapReduce job, which is invoked by Oozie, has done is it read the data from this location and write the data to this location. So the job is successful. So now you can confirm that Oozie is working, and you can turn around to the development team. And from there, they will actually develop the workflows and give it to you, and you can schedule them. Okay, that is about Oozie. We have understood how to set up Oozie, and also we have how to get the templates for most of the actions. And we modified the name node and job tracker information in the job.properties for MapReduce action, and we copied it into HDFS, and we have ran Oozie job command to submit the job, and we have seen from command prompt how to monitor the job, and then we also see how to get to the actual MapReduce logs and see whether the job is successful or not. So let me run that Oozie command again to see the status. It says succeeded, so it looks good. Okay, any questions on Oozie?